All right, so 19 says f of x equals x over x plus 2. It says, what points x, y on the graph have the property that the line tangent to the graph has a slope of a half? So slope of the tangent line means derivative, and we want that to be a half. So we're going to find the derivative and set it equal to a half. So this is going to be a quotient rule. So that is denominator times derivative of the numerator minus numerator times derivative of the denominator, which both those derivatives were just 1, over the denominator squared. And we want to set that equal to a half. So this numerator we've got, I'm basically going to ignore these 1s because multiplied by 1, nothing's going to change. We have x plus 2 minus x. So that's just going to be 2 for that numerator. I'm just copying down the rest of that. And then we're going to cross multiply. So that's going to give us x plus 2 squared equals 4. And when we square root, we're going to get positive 2 and negative 2. And then subtracting the 2, we're going to get that x is 0 and x is negative 4. And you can plug those back into the original function if you want, but I think we're probably going to be able to pick the answer choice just based on that. Yeah, it's going to be C, 0, 0, and negative 4, 2. So the one where x came out to 0 and negative 4. All right, and then we're going to look at number 20. All right, so the issue with integrating this, if you try just, a basic u substitution, it is not going to work. So this is going to be partial fractions. We're going to split it into 2 separate fractions. So let me write this off to the side. We'll have 5x over 8, or excuse me, 5x plus 8 over, and then we're going to factor this, and that will split into x plus 1, x plus 2. And so we're going to try to write this as something over x plus 1 plus something over x plus 2. And this is just mountains of algebra with like hardly any calculus. We're going to multiply through by this common denominator. Now you can write x plus 1, x plus 2, x plus 1, x plus 2 multiplied to each of these if you want. But for this first one, they're both going to cancel. And then for this one, we're going to have a times x plus 2. And then we'll have b times x plus 1. So I'm going to let x equal negative 2, and we'll see what happens. So if x is negative 2, this would be negative 10 plus 8, so that'll be negative 2, equals, this will be gone, that was the whole point. And if x is negative 2, this will be negative b. And so that gives us that b is 2, so we got that. And then we're going to let x equal negative 1 and see what happens. And I'm just picking the values that would make these 0 because that makes that part of it go away. So if x is negative 1, this is going to be negative 5 plus 8 would be 3. And this would be 1a. All right, so we get a is 3. So I'm going to put b is 2 and a is 3 back into this and just put it back into the integral. So we'll have integral from 0 to 1 of 3 over x plus 1 plus 2 over x plus 2 dx. And so both of those are going to end up being ln. This would be 3 ln of x plus 1 plus 2 ln of x plus 2 evaluated from 0 to 1. If you're like, this is so much work for a multiple choice question, I'm 100% with you. And this was the only step that was calculus. All the rest of this is just a big bunch of algebra. So you can complain if you want. I agree with you. That's kind of the way that this is. All right, so we're going to do upper boundary minus lower boundary. So if we plug in 1, we're going to get 3 ln of 2 plus 2 ln of 3. And then if we plug in 0, we're going to get 3 ln of 1. Ln of 1 is 0, so I'm just going to go ahead and put 0 for that. And then plus 2 ln of 2. So combining like terms, we have 3 ln of 2 minus 2 ln of 2. So that just leaves us with 1 ln of 2 plus 2 ln of 3. And then you'll notice that's not an answer choice. They go through all of these log properties. So again, not calculus. This is back from pre-calculus. Do you guys remember you're allowed to take this coefficient and put it back as the exponent? Every time I bring that up, everyone always stares at me like, no, we never learned that. You did, I swear. So we can do this as 3 squared. We're going to have ln of 2 plus ln of 9. And then the log property, when you're adding the logarithms, you can multiply. It's like your exponent rules. That's where these come from. You're multiplying, you add your exponents. So we're going to multiply those together, and we get ln of 18 for the final answer. So let me look back. So that one is C. And if you didn't like that question, I don't blame you one little bit, but that's the answer. All right, so let me see what you guys had written next. 22. Oh, whoops, sorry, that's 23. Let me scroll back here. All right, so number 22. So we've got sum from 0 to infinity, a sub n, x minus 3 to the n. It says that this converges at 5. Which of the following must be true? So this is centered at 3. So if we draw a number line, like we're centered at 3, and if it converges at 5, I know that the radius of convergence is at least 2. Like I can go 2 units in each direction. Like we know this converges at 5. I don't know whether it does at 1 or not, but it at least goes this far. It could go farther, but I know it's at least, since they said 5 and it's centered at 3, I know it at least goes that far. So let me read through the choices. It says the series diverges at 0. Well, I have no idea what's going on at 0 because that's outside of what I know is true. So it can't be A. B and C are diverges or converges at 1. I have no idea. I put a parenthesis here, but it might be a bracket. I have no idea what's going on at 1. Converges at 2. Now that's the one that's going to be the answer because I know it goes out at least this far. I know it converges at 2. So the answer is going to be D. Choice E was it converges at 6, and I have no idea what's going on there because that's beyond what they told us. So that one was D. All right, and then the next one that you guys wrote is 24. So I'm just trying to keep an eye on the time here. I was going to take questions on these until 3:10. Okay, cool. So I have 10 more minutes. All right, so 24. Let f be a differentiable function such that, all right, hold on a second, because let me write this all out so that we can see it. So this one is integration by parts. And I'm going to write out every last little thing here because it's been a while since we've done integration by parts, and I just want to review how you do every part of it. They sort of wrote out a good bit of the answer, but pretend that this wasn't here. Just want to show you again how to do integration by parts because, again, it's been like over a month since we've done that. So for this one, you would let u equal f of x, and dv is going to be the sine of x dx. So if we do the derivative of this, du is going to be f prime of x dx. And if we do the antiderivative of this, that's going to be negative cosine of x. So again, derivative of this gives you this. So then the formula is you do u times v. So that's going to be negative f of x cosine of x. So it's u times v, and that's how they got this. That's matching up. Minus integral v du. So these negatives are going to cancel. That's why this is positive. And it's v du. So it'll be f prime of x cosine of x dx. So just matching this up with what they gave us, here's this first part. And then all of this matches exactly this is the part that goes together. So we know that f prime has to equal 4x cubed. So that's f prime. And I think they asked what's f of x. Let me go back a second. But yes, which of the following could be f of x? Well, if this is f prime, to get f of x, we're just going to do the antiderivative, which would be x to the fourth. So you could do this problem without doing all the work that I did. You could just look at that part right there and go, oh, it'll be the antiderivative. But I wanted to go through the whole formula because, again, it's been a while since we did that, and I just wanted to review all of it. So that one was E. All right, so I've got a little bit less than 10 minutes to do a few more from this section, and then we'll go and look at the last section. So do you guys want to pick? I can probably do like 2 or 3 more from this section here. And I think I made it go all the way up through 83, I think is what I made it go through. All right, 26. All right, so this says, what is the slope of the line tangent to the polar curve r equals 1 plus 2 sine of theta at theta equals 0. This is another problem that's like kind of tedious, but not necessarily hard. It's just going to be a lot of writing. So we've got to get x and we've got to get y. So x is r cosine of theta. So this is r. So it's going to be all of that times cosine of theta. And y is r sine theta. So it's going to be all of this. Just missed the 2 there. Times sine of theta. And so when we go to do dy dx, we're going to do the derivative of y over the derivative of x. And they're both going to be product rules. So like I said, it's tedious with how much you have to write, but not difficult as long as you know the product rule. All right, so derivative for y, so that is going to be first. So first times derivative of the second, derivative of sine will be cosine, plus the second, so sine of theta, times derivative of the first, which will be 2 cosine theta. There's that product rule. And then now we're going to do this one. So again, it's a product rule. So first times derivative of the second, which is negative sine, plus the second times derivative of the first, which again is 2 cosine theta. And so we want to evaluate this where theta is 0. So I'm going to plug in 0 for theta. Now, the nice thing about sine of 0 is 0, so it's going to make a lot of this go away. And cosine of 0 is 1. So I know this looks big and bad, but we're going to end up with like a bunch of zeros and ones here. So this first part is going to be 1 plus nothing. So it's just 1 cosine of 0 is 1. Plus sine of 0 is 0. So this whole thing is gone. It's all just going to be nothing. Over 1 times 0. So actually that whole first part is going to be 0 plus 1 times 2 times 1. So times 2. So the answer to the whole thing ends up just being a half, which feels very anticlimactic after all of that. So that one is B. All right, and then I think somebody typed another one in there, 28. All right, so they tell us g of 1 is 6, g prime of 1 is 3, and then this is what they're asking us for. Limit as x goes to 1, integral, so we have an integral inside of a limit here. All right, so we're going to plug in 1 for x, and if you plug in 1, integral from 1 to 1 is going to be nothing, so that's 0. And then down here, they said g of 1 was 6, so you get 6 minus 6, which is 0. So this is going to be L'Hopital's rule. So we're going to do the derivative of the numerator and the derivative of the denominator. So if you do the derivative of the numerator, derivative and integral cancel out. You're just going to have g of x. And then down here, you're going to have derivative of this would be g prime of x. 6 is a constant, so that's gone. And now we're going to plug in 1 again. So g of 1 is 6. And then g prime of 1 is 3. So 6 over 3 gives you 2. So that one is D. All right, and I can do one more from this section. Would you guys like to pick one more? Again, it went all the way up through 83, how I was breaking this apart here. All right, 77. Now this is a calculator one, so we may need a calculator for it. I'm trying to scroll through. Oh yeah, look at these answer choices. These all have these decimals. And that's how you kind of know whether you actually need a calculator or not, is if you look at the answer choices and there's all kinds of decimals, and you know you need a calculator. All right, so they give us f of x equals e to the x, g of x equals x to the fourth. On what intervals is the rate of change of f of x greater than the rate of change of g of x? So we want to know, where is f prime greater than g prime? So we're going to find the derivatives, put them in the calculator, and just look at where this is true. So derivative for f is just e to the x. Derivative for g is 4x cubed. And so I'm going to get out the calculator and we'll type those in. Sorry, I need to move my screen back here. All right, so I'm going to do e to the x in y1 and then 4x to the third in y2. And let me see what kind of intervals they have. I think they were all pretty tiny. Now some of them go up to 8. So I'm gonna go to window. You know what? I'm just gonna leave it standard to start with. Let me just hit graph and we'll see what we get here. I have a feeling I'm gonna have to change it, but all right. So here's your exponential. This is e to the x, and then here is our 4x cubed. And so we are looking for where, gosh, which one was it? We want the e to the x to be above the 4x cubed. So I wish I had one of those calculators where it did these different colors, because I know this is hard to see here. So the e to the x is above the 4x cubed for all of this portion up until this intersection. So let me calculate this intersection here. Intersect. First curve, enter. Second curve, enter. Guess. The cursor is close enough to the intersection, so I'm just going to hit enter. And so we get, I was thinking about it. Oh, did I hit the wrong thing there? I must have done the wrong button. Intersection. First curve, second curve. Guess. There we go. I must have hit a button. I'm so sorry. So we want everything from negative infinity up until 0.831. But I think if we keep going, this is gonna overtake the other one. Let me see. Let me make this window. I think it's gonna have to be quite large. You know, let me make it like 500. Let's see what happens. All right, so there's the exponential. Oh, that still didn't catch up. I'm gonna have to make it even bigger. I'm sorry, I don't remember how large I have to make this. Let me make it 1,000. Yep, I'm almost there. Let me make it 2,000. I don't want to mess around with this anymore. All right, so there's the exponential. There's the 4x to the third. Do you guys see how there's another intersection here where it overtakes it again? So let me calculate that one. So intersect. So first curve, second curve isn't going to change. Move the cursor over until I get to this intersection. So 7.384. So that's where the e to the x kind of overtakes that again. So I want 7.384 onward. So let me go back to the choices here. Let's see. So that one is B. All right. Oh gosh, I kind of went over the time there. Whatever time your clock says, let me hit stop on the recording.